Geometry Lesson 2.2. We're going to learn about statements and truth values. Before we proceed, please pause the video, get some paper and something to write with, because you are going to be taking notes. It's very important during this lesson that you make a sheet that has all the tables that we are going to cover, so that they're in front of you when we do homework. So what is truth? The dictionary defines truth as fact or actuality. In John 14:6, Jesus said that He is the way and the truth and the life, and no one comes to the Father except through me. As Christians, we believe this to be true, because we believe that the written word of the Bible is inspired by God. Let's look at some other statements to discern if they are true. Christ is the only way to salvation. True or false? This is a true statement. Everyone is a sinner, and the wages of sin is death. This is a true statement. Everyone is not a sinner, and the wages of sin is death. This statement is false. The first part of this compound sentence is not correct, so the whole statement is not correct. Everyone is not a sinner, or the wages of sin is death. This is true, because this has the word "or" in the sentence. We can weigh and balance this by looking at one part and then the other part and making a determination. In the study of logic, a statement is a sentence that's either true or false. Let's look at a few more examples. The Bible is the Word of God. We've learned that that is true. 2 times 3 equals 9. This statement is false, because 2 times 3 equals 6. X plus 5 equals 23. This is not a statement unless we know the value of X. Life began through the act of creation by God. This is true. We've learned this from the Bible. 8 plus 7 equals 15. This statement is true. Statements can be negated. The negation of a true statement looks like this. The true statement, gold is a precious metal, when negated becomes gold is not a precious metal. A statement's negation always has the opposite truth value. So for your notes, you should have the word negated in its definition and the last statement on this slide should also be in your notes. In the study of logic, statements are usually symbolized by a letter such as P or Q. In algebra, you learned to replace numerical terms with variables. This is just a variable for logic. The negation of a statement is symbolized by this little symbol here, a little squiggly line, P. And the way that we read that is as not P. So the negation of a statement is symbolized by not P. Example, statement P. A year is a 12-month period. Not P. A year is not a 12-month period. When you negate a sentence, you're not looking for the sentence that's negated to be true or to be false. You're just doing the negation. This is very similar to when we do the complement of a set. Universal quantifiers. Words such as all, every, some, or there exists are used to quantify statements. The universal quantifiers all and every are symbolized by an upside-down A. Example, if P is men are sinners, then this symbol in front of P is all men are sinners. So this symbol signifies the word all. We also have existential quantifiers. Words such as one or more are symbolized by the backwards symbol E. If Q is boys like to play baseball, then this symbol in front of Q is there exists a boy who likes to play baseball, or some boys like to play baseball. We have to be careful when negating statements containing quantifiers. The negation of a statement must have the opposite truth value. Let me say that again. The negation of a statement must have the opposite truth value. Make sure that's in your notes. Let's make R represent a false statement. All roses are pink. Now let's make not R, which is the negation of R, as a true statement. If we begin and we make some negations, we might say all roses are not pink, or no roses are pink. But these would not work because they are not true. Remember, we started with a false statement. We now need to make a true statement. However, some roses are not pink, or not all roses are pink, would work. These are statements that are true. So for example 1, let's negate the statements. Remember, the goal is to give the opposite of the original statement. So P, there exists a student who gets straight A's. Not P, no student, or there does not exist a student who gets straight A's. Q, some pies are not cherry pies. Not Q, all pies are cherry pies. R, no square is a circle. Not R, there exists a square that is a circle. This is our first truth tables. Truth tables show a summary of all possible truth values for given statements. The first column of the table below shows that statement P has only 2 possible values. Each row then shows the corresponding value of not P. Don't make this any more difficult than it is. You might be thinking, okay, how do they get these? If I give you a statement, that statement is either true or false. There's the true and there's the false. If we negate it, the negation of true is false. The negation of false is true. So this is the first table you should put on your sheet. Simple statements can be combined to form compound statements. Both simple statements, so both of the simple statements, must be true for a conjunction to be true. What's a conjunction? A conjunction is a compound statement formed by connecting 2 statements with the word and. The conjunction P and Q is denoted by the caret symbol. So this reads P and Q. You've learned about conjunctions before in English and in math. Let's go over a false statement. The conjunction Christmas is in December and February has 31 days is false, because the second statement is false. February has 28 or 29 days. True. The statement Christmas is in December and January has 31 days is true because both statements are true. On the sheet of paper where you wrote your truth table, put conjunctions must, something like conjunctions, simple statements must be true for the conjunction to be true. Here's another truth table. This truth table is a little longer now because we've added the P and Q. Anytime you add another statement, what's going to happen is you'll add rows. We have our original true and we have our original false, but now we also have another true and false statement. You might be thinking, how did these get lined up this way? This is a choice that your curriculum has made and has been found to be easier to remember. So just begin by knowing that with conjunctions, you'll use this table, and it'll be true, true, false, false. And for the second statement, it'll be true, false, true, false. This gives us the full combination of possibilities in our logical statements. Now, for our answer to our conjunction to be true, both statements must be true. That should be in your notes next to your table. So, true, true, and true. This statement has a false statement in it, so it's false. This statement also has false in it, so its answer is false. And false and false would also be false. Stop the video and go ahead and make this truth table and put your notes about conjunctions next to it. In formal logic, we also have a disjunction. So we had a conjunction, which is the word and now we have a disjunction. A disjunction is true whenever at least one of the statements is true. So one statement. So in your notes you could have had conjunction, two statements must be true to be true. With a disjunction, one statement must be true for the answer to be true. So the disjunction, Christmas is in December, or February has 31 days, is true with a disjunction because the first statement is true. With a disjunction, we use the symbol V. It's a large V. So it's upside down compared to the caret that we used for conjunction. And if just one statement's true, then the answer will be true. So we have true, true, and true. True, false, and true. Remember, in conjunctions, this would have been false because there was a false statement. Now, if there's a true statement, it'll be a true answer. False, true, and false, false, false. Now, on your same piece of paper, make this table. You should now have 3 tables on your paper. Make sure you have the notes that describe the table with the table. Example 2, true or false. Any 3 points are collinear, or the union of opposite rays form a right angle. Let's examine each statement. Are any 3 points collinear? No. 2 points can be collinear, but with 3 points, one of the points could be non-collinear. Let me show you an illustration. Go ahead. Pen. So if you have 2 points, they'll always be collinear because you can connect them with a line. But a third point might be on the line, but it might be over here. Now let's look at statement 2. Does the union of opposite rays form a right angle? No. The union of opposite rays forms a straight angle. That is the definition of the union of opposite rays. So both of these statements were not true. Truth tables are helpful for determining the truth values of more complicated expressions also. The first columns of your truth tables should always list all possible combinations of true or false statements. You don't have to come up with these tables on your own. Your book is going to show you what the setup is for those tables. If there are any unknown number of statements, n, there will be 2 to the nth power rows in the truth table. You'll see how this works with our next combinations. List these combinations systematically. So there is a system for listing them. You're going to learn it from your book. You need to memorize what those tables are. Then fill a column representing each successive statement using the rules we've learned for negation, for conjunction, and for disjunction. This is example 3 from your book on page 62. We're going to look at a statement which is P and Q or not R. Note that Q or not R is in parentheses. And what we're going to do is start by listing the conditions of P and Q. And there are 8 possible combinations. This is because we've added now a third column of R. We're going to negate each condition after we've gone ahead and listed our possible conditions for P and Q. So we begin with P. True, 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 true. False, 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 false. Now where did I get that? The book is telling you this is the way you set up your table anytime that you have 3 variables. Q will be true, true, false, false, true, true, false, false. And R will be true, false, true, false, true, false, true, false. So this is how you set up a table with 3 variables. The first thing we'll do is the easiest thing we can do, and we'll negate R. So we're going to negate every condition in R. So true will become false. False will become true. True, false, false, true, true, false, false, true, true, false, false, true. Now, because Q or not R is in parentheses, we will work that first. We go back and we remember the values and the way that we deal with our disjunctions. In a disjunction, we remember that for the answer to be true, one of the statements needs to be true. So, on your first statement right here, we look at Q, the column Q, because that's what's in this statement. And we say true, and we say true, false, because we're doing Q or not R. So true, false, and with true and false, there is a true statement, so our answer will be true. True, true, our answer will be true. False, false, our answer will be false. There's no true statement in there. False, 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 true, true. True, false will be true. True, true will be true. False, false, false. And false, true. And the last column is false, true, and true. So once again, we look at the Q column, This is an OR, so if one statement is true, the answer will be true. We also look at the not OR column and make that answer. So once again, Q is true, not R is false. So true, false would be true. Now that we have these answers, we can go ahead and do our full statement, and we're going to add the column P. Now this is an AND. So with an AND, you have to have you need two true statements to get a true answer. If there's a false in there, it will be false. So we look at P, we'll look at Q, and we'll look at our answer right here. I'm sorry. We'll look at P and our answer to determine this answer. So true, true, true. True, true, true. True, false, false. True, true, true. False, true, false. False, true, false. False, false, false. False, true, false. So with the AND, anytime there's a false statement, you will have a false answer. So I know this is a lot to think of. One of the things that might help is to make a table big enough where you can cover over the columns you don't need to look at. When you get towards this answer, you could cover over Q and R and not R, and then you would just see the answers you're supposed to look at. If you have your notes next to your tables, you can remember, once again, that with conjunctions, both statements must be true for the answer to be true. And with disjunctions, if one statement is true, then the answer is true. My recommendation is to pause the recording and listen to what I'm saying about the tables. Have all the tables on one sheet of paper so that you can compare them and start working through each problem. I'm going to go ahead and do a couple of homework problems right now, and hopefully this will help. Let's take a look at homework problem, or a problem similar to one of your homework problems, and this is number 12. The instructions are: state whether each statement is a disjunction D or a conjunction C, and whether it is true or false. So these are two-part answers. So 12. A spider is an insect, or a dolphin is a fish. Well, we have the disjunction or, so we know that. And we're also asked to say whether it's true or false. With a disjunction, if only one statement is true, then the answer will be true. A spider is an insect, that's false. That statement is false. A dolphin is a fish, that statement is also false. So our answer for this problem would be disjunction, which is the V, and false. Let's move on to number 15. Number 15 is the same instructions. Now here we have a conjunction, and I'm going to mark that down right now. There's a conjunction. 6 plus 3 equals 9 is true. 12 minus 8 equals 4 is true. With a conjunction, both statements must be true for the answer to be true. They are both true, so our answer is true. Number 25. They ask us to negate each statement. So the statement is, for all numbers x, x plus 5 equals 5 plus x. Our negation would be something like, there exists a number such that x plus 5 is not equal to 5 plus x. Now I know that's a long sentence. Please do not answer this or a problem like this by just putting x plus 5 is not equal to 5 plus x. These answers require a full sentence. Problems number 31 and 32. Statements S and Q. The statement S is Emma tutors Sophia. The statement Q is Sophia is from Pennsylvania. They give us two statements, not S or Q. The other statement is, not S and Q. So this is conjunction. This is also conjunction, S and not Q. So we take our statement S, Emma does not tutor Sophia, because we need to negate it. Who is from Pennsylvania? We just write our second statement with a word that won't link it together properly. The second statement, S and not Q, we now take Emma tutors Sophia, who is not from Pennsylvania. So we've negated the second statement. In this one, we negated the first statement. With both of them, we drew them together with a word that would make the sentence fit. So this is a difficult lesson. I realize it will take you a while to get through it. Be sure to ask questions, and we'll see you at the next video.